Hi everyone, and hello and welcome to the My DevSecOps community. For those of you who are joining us for the first time, we're an inclusive community that educates and enables developers in application security. Today, I'm really lucky to be joined by Barak, who is the CTO and co-founder of Bridgecrew, and he's going to be talking about cloud configuration detection in runtime versus static analysis. So I'm really excited. But before we say hello to Barak, I quickly want to introduce myself. So my name's Sam, for those of you who don't know me, and I'm the community manager here. So any sessions you'd like to see, any feedback, if you'd like to be a speaker on one of our episodes, please get in touch. You can do that at mydevsecops.io or on our Slack community. Slack's actually the best way to interact with our speaker today. So if you're not part of the community, if you jump onto the website, mydevsecops.io, you'll get the link to the Slack and join live sessions, and I'll be feeding those questions live across to Barak during the session. If you're watching this pre-recorded at a later date, he is a member of the community, so please feel free to pop those questions in whenever they arise, and we'll either get them answered by him or one of our other community members. So yeah, really excited to have him here. My DevSecOps is actually brought to you by Sneak. Sneak aims to create a vendor-neutral space to share knowledge and best practices related to software security. So a huge thanks to them. But I think that's enough from me. So hi, Barak, welcome.
Hi, Sam. Thank you. Thank you for having me. Actually, I'm very excited. Hi, everyone, too.
It's a pleasure to have you. Obviously, you've been a community member for quite some time, so I'm quite excited just for this session.
Yep. All right. Let's kick it off.
Let's kick it off.
Just share my screen. Right? Can you see my screen?
I can.
All right. Okay. So thanks, Sam. Welcome, everybody. And today we're going to talk about some cloud misconfigs. We'll try to focus on misconfigs operating in the public cloud providers like AWS, GCP, and Azure, and discuss some practical ways to stop them using both runtime analysis and static analysis, and compare the two different approaches. So a few words about myself, my background, in case it's the first time that we're meeting, it is for the most of you. So I'm the CTO and co-founder of a cloud security startup named Bridgecrew that was founded around a year ago. And our goal is to make cloud security much simpler, but that's for another talk. In Bridgecrew, I'm involved with a few open source projects around AWS security, Terraform security, and GCP that I either co-maintain or continuously contribute to. And in my previous roles, I used to create machine learning algorithms over data science of OS data and network data. And if any of those areas interest you, you can ping me on Twitter, so see these projects on Slack, or on GitHub. If you look for me in Twitter, it's Barak Shuster Kamokes. So what's on the agenda for today? We prepared some very interesting topics lined up. We'll start with some basic settings to get familiar with the different terms and terminology of the AWS configuration capabilities. And then we'll see the common areas between runtime and build time or static analysis of cloud configuration. And we will cover the basic concepts, and then we'll run through a demo of each one of those with real open source tools on a live environment that I prepared before this session. Let's start by where does those bad configurations come from? We're all part of a movement. We're all part of the Agile movement, the DevOps movement, and today the DevSecOps movement. And as part of this movement, we do not operate the same way we used to 2 or 3 years back. When we are building a new AWS application, usually we'll say, should we build a service or buy one, or use an open source one? As someone that manages a security engineering team, I always tell my engineers to use an existing template, either an open source template or one that can be acquired. The reason I'm doing that is because I want us to be focused on the heavy lifting that is required for our own application. and I want us to move as fast as possible and grow our app like crazy, from scale out capabilities, customer value, new features, and all of those areas. So being in this mindset of acquiring new services from a managed service like AWS, for example, acquiring an AWS Elasticsearch or using a default encryption capability of AWS, it gives me a ton of capabilities to move fast. But on the other hand, I'm importing a lot of risks and in different shapes or forms of configurations that I can have mistakes on since I've not created this service myself. So where does those configurations come from? They're coming from the different public registries. Those can be the AWS CloudFormation registry, the Terraform public registry, GitHub open source projects with Terraform or CloudFormation registries, or just do-it-yourself projects. So all of those different templates that come from those common registries are usually containing boilerplate and blueprint of how your environment will look like. They do not have any business logic internally. They are just the logic to provision new resources under your account. Their goal is to help you build fast a common infrastructure with the least amount of work and effort that is required from you. The result is that you will not be familiar with the configuration or where is it coming from. But even if you build the templates yourself, often it's being deployed by different teams and you are not always aware of the different configurations that is being created inside your own engineering powerhouse. So what do we do? Before we start with the fancy tech around how we solve this problem, let's try to understand who owns it inside the organization. What we're seeing working with different security engineering team, or what I've seen in my past roles, is basically three different approaches. The first one is just to be afraid, to halt the cloud adoption. And since a lot of security teams are yet to be familiar with a non-air-gapped environment, they're just taking the time to learn. So they're halting the cloud adoption. It's not the best way to solve a problem by just avoiding it. The other way is just to withdraw all of the controls and saying everything that is important should be on-prem, and everything that is not important or not mission critical can be on the cloud. But things can get leaked, and also there are tons of risk where an access key can be obtained by a malicious user and can be used to acquire resources under your account. And the third is that just to shift all of the responsibility of those cloud configurations back from the security team into the engineering team. So what we're seeing mostly on younger and cloud native shops is a clear motion where infrastructure development is moving from security team into the hands of cloud architects and application developers. We're seeing that most of the cloud native organization moving from centralized team that are threat oriented and are mainly around security into decentralized responsibility models, where security responsibility is shifting back to the developers. Just like QA is scattered in nowadays across different teams, and it's not a whole big team. And DevOps is the same, scattered across the different pods or squads. The same we can say for these security operations in the cloud. Those responsibilities are moving into the developers and SREs and DevOps engineers. Before this change started to happen, it really came down to the developers who've gotten very used to deploying new application inside data centers to have the awareness that they are in an air-gapped environment, in an on-premise environment. They had like firewalls and WAFs and things to protect them. And they always had the security team to hold the keys to the kingdom and watch their back. they knew that they can count on another team and their responsibility is not theirs. In the public cloud, that's all changed. It doesn't exist the same way. Developers don't have someone who's babysitting them or watching their back. They don't always have someone to consult with, and the process looks completely different. And really, it comes down to a cultural shift that needs to happen. So let's talk about the actual configuration errors we're seeing out in the wild. There is an awesome research by Palo Alto, Unit 42 guys. They actually took 200,000 different templates. Those can be Terraform templates, Kubernetes, CloudFormation templates. And what they tried to do is to understand, are those templates insecure? And what they found out is that actually 43% of the cloud databases mentioned on those templates does not have any encryption enabled, which is a huge amount of databases without encryption. And 76% of the cloud workloads had SSH port exposed to the entire world. So those common misconfigs are actually in the open source already. If you will use an open source template, you might be exposed to a specific risk. And specifically, my personal favorite is finding hard-coded access keys over GitHub. We're seeing a lot of customers and a lot of AWS environments that are getting crypto mining actions from access keys that are just there in the wild. So let's conclude the first setup phase. Developers are awesome and they want to move fast. They build things super fast, and it enables our cloud native company to grow and scale out by the business needs. The third thing is there are a lot of boilerplates and templates that you can get from the internet, from the different registries. And one thing to keep in mind is that developers are not aware of the end result of misconfigs that might come in from an open source template project. So where do we start handling those different templates and those different misconfigs? So what we would like to do in this session is to set up our own detection capability using open source tool. Our goal is to defend our organization, and we want to defend our data that we hold, because this data is probably belongs to our customers. And our goal is also to do that at scale. It's very hard to do. It's very simple to do it over, for example, one bucket or one AWS account. But to actually do that on an engineering team that is on a fairly amount size, it requires some automations that we'll walk through how to do that. The good news about trying to build a stack that is about finding vulnerabilities on misconfigs in the cloud is that there is a ton of content and pre-baked open source tools that can give you some value from the first second. So let's start with the first approach, which is runtime detection or runtime analysis of cloud configuration. We're talking about tracking all configuration that are happening on cloud provider console. That can be the AWS console web UI or APIs or even the Python SDKs. Anything that is cloud provider comes in that section, which is API-based or event-based or runtime-based. We're seeing two main approaches to runtime detection. One is event-based analysis or activity-based analysis. This is a classic security use case where you take the different activity logs from the environment, throw them through a log aggregator, which is usually called a SIEM, query it, and boom, you have your detection capability. You can search for overprivileged activity, you can identify manual changes in IAM, you can find unused networking configuration, and you can alert over malicious activity. This is called activity-based or event-based detection. The second approach is where cloud providers are in an entirely different ballgame than the on-premise providers. Most of the cloud providers have their motto of being API first. And since they have an API to query every different configuration, it's been very interesting to see how much detection capabilities you can do or you can create from API polling only. Our favorite security projects are actually a clever combination between activity data and API data. Those enables you to create some kind of lightweight CMDB and query it for different risks. And the projects that you can see here that are doing both is actually the yellow one that is called Cloud Custodian, which does both event or activity-based detections, and it even has some enforcement capabilities, and it also has API polling capabilities. So let's drill down on the event-based. So good examples of projects that are doing that is Elasticsearch, the open source open distro, has some alerting capabilities, and the same for StreamAlert. Those projects help you to capture the relevant log data from the cloud provider, different API audits or RDS or queries, database changes. It helps you to contextualize using different enrichments and filter the different noise you can see in those activities, and identify the misconfigs that happened in that environment. One thing I like to do is to whitelist a baseline of familiar activity that is okay and is good to happen. For example, Terraform changes in my environment are usually not anomalous if the pipeline is secured. And human-based activity is stuff that in production account are stuff that I would like to get an alarm on. And there are the classic stuff of correlating malicious IPs and other stuff, malicious files. But those are also being handled by the cloud providers using a managed service like Guardian. As for the second approach, there is an awesome tool called Prowler. It's actually one of my favorites, and the reasons is because it has tons of content, over 100 different detection capabilities, both of best practices and compliance like PCI checks and HIPAA and CIS benchmark. So it has tons of content. It's very easy to install and set up, and it can run securely from anywhere. And what it does is to map the critical configuration and identify the desired state. You can trigger it using a scheduled routine to do a continuous verification of your cloud configuration. And the end result is an alert or identification of an issue that you should take a look at. So let's take a look on how should we deploy a tool like Prowler on a prod environment. And then we'll go through a quick terminal session where I deployed Prowler on my endpoint on my laptop, and we will query a demo environment and take a look over the results. So on the left side, what I have is my source account, which is can be my production account. It has some databases, IAM roles, EC2 instances, and S3 buckets. And what I want to do is to have a security account that queries it for the different misconfigs. So I've decided to deploy Prowler on an ECS cluster as a Docker container and query the different resources over time. And I have a CloudWatch trigger that just do that scheduling on an hourly basis. On every time Prowler detects, for example, an open S3 bucket to the world, I will get an alarm for that and trigger a remediation action like making it private or encrypting it. So let's go through a quick demo of Prowler. All right. So what I did before is to create an environment with a public S3 bucket. The environment profile in my AWS credential is named prod, and it is deployed on US East 1. And what I will check is this check that looks for public S3 buckets that are open to the world. Okay, good. It already find 2 buckets. One that is a public one called Acme My DevSecOps Data. This bucket is public and exposed to everybody from the internet for a read, and one private one, which is good. Now we'll give a try to another check that is nice. And we will try to look for plain text access keys that, as we've discussed, are in the area of crypto mining risk. So what we're doing here is querying each and every EC2 instance in the environment. And we're looking on the user data, the provisioning code of each EC2. This data can be shared if you're doing some APIs or provisioning logic is public and you've taken some of that from the internet, or if you have cross-account rules with other third parties. So what we've seen here is that we have a potential secret that can be an SSL key, that can be an access key, or database connection string in this AWS instance. Let's try to figure out how this secret looks like. So secrets are are encoded in byte 64. So we'll decode those, and we will see that we have here access keys on plain text on this specific instance. Detecting those means that now, as an action, I need to deactivate those keys and make sure that non-pieces of my code are using those keys, and that it is not committed to my Git repository. All right, so that was cool. We created an environment, and we've detected a public S3 bucket and some hard-coded access keys. And it seems like the problem is solved, right? But actually, it's really not enough. I can detect hundreds of buckets that are lack of encryptions, or hundreds of RDS instances that requires logging. But the thing is that on the next morning, after remediating those either manually or using script, I will get those configuration overridden again. And the reason is because continuous deployment exists. We have the Ansible scripts that are rerunning and overriding our infrastructure configuration. And the same can happen for Terraform, CloudFormation, Chef, or others. So it's becoming an endless chase between security to the developers that are overriding, using continuous deployment, the different AWS configurations using the infrastructure code. So what it means is, instead of focusing on the production environment analysis, the runtime analysis, we should try to focus our tests of security on the Terraform plans and CloudFormation stacks to find the misconfigs before they hit the production account. This is why we've decided to open source a project named Chekhov. So Chekhov is a static analysis tool that looks for misconfigs in infrastructure code. It's looking for misconfigs in Terraform code and in CloudFormation code. It's completely open source. It's Apache 2 licensed, just as Prowler. And it enables an automatic review of your infrastructure code as you add more and more cloud resources to it. It comes with 100 different built-in checks, and it has the capability to ignore checks or to add some extensions and some CI/CD integrations. By the way, if anyone wants to contribute, you're more than welcome. There are tons of tasks and more checks that we'd like to add to the different cloud providers. So how would you use a static analyzer like Chekhov? You will trigger an event from a change request, a pull request that contains a code change. On every resource that is being added or modified in the Terraform code of the environment, you will trigger checkoff to run its infrastructure tests. After reviewing the Terraform code, checkoff might approve or reject the change request. And from there, GitHub or your other CI or CD system can trigger a deployment of your Terraform code. And this Terraform code can, after it has a secure infrastructure written in it, can apply the different resources on your AWS account. So let's start with an example. Let's bring checkoff in. So I have here a project with a Terraform directory with the same resources that I created that Prowler detected. So let's go and take a look on the S3 templates. So Terraform is a declarative language that allows me to declare how I want resource to be provisioned. So over here, I've declared that I want an S3 bucket to be provisioned named data, which is the one that was exposed. And I want it to be public, which is a very bad practice to do, but it can happen because any engineer can write any configuration that is like, and there is no enforcement about it. And I have some more buckets with different configurations on. And I have another Terraform template of EC2 instances. And over here, I've created an EC2 from a dynamic AMI with a dynamic security group, but with user data that contains those hard-coded access keys that we've seen before. So let's see, and those resources are yet to be provisioned. Let's see if we can detect them without applying them or deploying them into the environment. So to do that, we will just install checkoff, which is very simple. It's a pip install checkoff. I have it already installed. So what we will do is we'll run checkoff minus directory Terraform. And from that point, what it will do is to scan the code in the directory. And what it found is like a ton of issues in the environment. So it had 20 failed checks and 12 task checks. So we can see that I have a bucket of financial data that is not public. That's good. But what about the others? So I can see that I have buckets without encryption at rest, without logging enabled. And also we can find here the EC2 instance that had those hard-coded access keys. So it looks like we're good to go. We can let checkoff run on our CI/CD pipeline and prevent code from being deployed into the environment with sensitive data or misconfigurations in the cloud. But is that really enough? And the answer is still no. We want to be to make it more automated. We want to make it more distributed across the team. So how can I scan my infrastructure without provisioning it to AWS while I'm developing it? So the answer here is just like you would want like to have code to pass without linters, without looking pretty or being maintainable. You can use the same approach on the static analyzer. So let's go back to that repository where I have this Terraform file and take a look on what I've done, if I've done any Git changes locally, any file changes that I'd like to commit. And the answer is yes. I created those files, this EC2 file, with some misconfigs and vulnerabilities, but it is still not committed to my source code. So let's try to commit that. Before committing that file, we'll see that I have defined a pre-commit hook over here. And what this pre-commit hook looks like, it fetches the checkoff tool from the Git repository. It's taking the master release, and it's always running on every commit. Now, what I will try to do is to commit the changes that I've just created. So we'll type in git commit, and we get the checkable output on each failed commit. And if we'll go and we can see that it is on a failed status and a bad exit code. So not only that the CI/CD pipeline will block any deployment of bad configuration from arriving to prod, it will even prevent me from doing that locally on my endpoint, on my laptop while developing it. So that's cool. It was blocked. So how does that look like on a large engineering team scale? You will probably would like to integrate that with your CI/CD tools like Jenkins. And the way it would look like is just like this example. You will have like failed builds and partially, it depends on the threshold that you define, partially failed builds that was blocked from being deployed using the static analyzer. And if you would like to build a trend graph, you can see that your team is getting better in building a security infrastructure. Over here, we can see that we had a ton of red checks, which means bad configs on the environment. But we can see that our engineering team is being educated over time and getting the configuration right. So Chekhov is fairly new. It exists for 3 months, but it already has over 100,000 downloads, and it is kind of battle tested in very large companies. And it is, again, completely open source, and you're highly welcome to use it and contribute to it. So feel free to give it a try. So let's take a look again on the 2 different approaches and compare the 2. So we had Prowler, which does API polling for runtime analysis of the account, and Chekhov that did static analysis. So Prowler is usually maintained by a central team, which is the security team or production team. It's usually part of the production monitoring, and it is scalable across multiple accounts. If you have multiple of those, you can have cross accounts roles from the security account to all of your different projects and environments. Another good thing about it is that it's aware of the runtime behavior, meaning if someone will do a change only on production, like an admin will change a configuration, not through a code, Prowler will detect that. It takes several minutes to identify the change because it's relying on a scheduled mechanism, and it depends on your scheduling. And it addresses compliance, security teams, and SREs, which is good, but it's largely a small part of your engineering team. For static configuration analysis, the good thing about it is distributed by design in the engineering team using the pre-commit hooks. It can be part of your CI/CD pipeline. You can run it on as much Git repositories as you'd like. One downside of it is that if some admin will make a production change and not a code change, the static analyzer would never know that. But it's really fast. It takes seconds to identify, and the address of it is, as we mentioned, is the developers. So if you want to build like a secure program, a security program for your cloud infrastructure, what should you do? We've talked about both runtime and build time analysis. What's the best choice? So actually the answer is that you should do both. And the way you would do that is integrating probably Chekhov or other tools like OPA and TFSec on the build time, meaning on each pull request, you will scan your infrastructure code. And on runtime, you will have your production team or security team monitoring your cloud account for every manual possible change. All right, cool. Any questions?
Perfect. Yes, we actually have one come in. Ooh, another one as well. We'd like to know if you have any examples of Terraform or cloud configuration templates that people can play with if they haven't really done any sort of templating before.
All right. So if it's about taking an existing template, there is a website called registry.terraform.io. It's the official Terraform registry. You can take and play with templates from there. And if it's about a vulnerable Terraform, there are a bunch of examples in blog posts, and we're going to publish one soon for researching and security best practices.
Amazing. It was about vulnerability. So we will let Hazana know. We also wanted to know if, hold on, I've actually got to read this question. Apologies. Okay, so does he have to set up Prowler on a different AWS account, or can he have it in the same AWS account? What do you advise for Prowler?
So you can set up Prowler everywhere. You can do it on the laptop like I did on my demo. But actually, AWS recommends to have a security centralized account, having all of the logs going through that account and have a centralized security hub application. But you can deploy it on your endpoint, on your AWS account without cross-account roles, or on a separate account. I would recommend a separate one for easier management.
Okay, perfect. That's very useful. Cool. I think that is all the questions that we have come through. We'll give it a few more seconds for anyone who hasn't sent through any questions, but thank you again so much, Barak, for the session. Definitely was very interesting. And I tried to get those links you're talking about across onto Slack for anyone following through, but we'll also get them on the show notes on the website. So anything that we missed, any of these sort of registries and things like that, we will link to in the show notes. But again, thank you so much. We really enjoyed having you, and I hope that we have you again soon.
All right. Thank you. Stay safe, everybody.
Yeah. So those of you who are interested, from our next session is in 2 weeks' time, and hopefully you can join us for that. If you enjoyed today's session, please share with your friends, your colleagues, get involved. If there's anything you'd like to see, any specific topics, this community is definitely for you. So ping me a message and we will find a speaker to cover those sessions. If you are a speaker, as I said, we're always looking for new speakers, so get in touch. You can find us on mydevsecops.io. And we will see you again in 2 weeks' time. So thanks again.